As we've seen, the electrical system is mostly automatic, with built-in voltage and load protection and redundancy. The EPCU reconfigures the DC power flow for a single DC power failure or a double failure. The real problems start with a triple failure. Your actions are limited to resetting a generator, battery switch or bus fault reset switch, monitoring caution and warning lights, and monitoring voltage and load on the MFD. In this lesson, we're not going to go into detail on combinations of every electrical fault, but we'll give you an understanding of what's happening for some important abnormal conditions. Battery hot are the only warnings in the electrical system. All other abnormal conditions are cautions. Verify the overheat on the MFD, then switch off the battery from its charging bus. Touch the switch. If battery temperature continues to rise, according to checklist, land at the nearest suitable airport. In addition to battery hot warnings, there are also battery cautions. These come on when the battery is not being recharged by its charging bus. Try cycling the relevant battery switch off, then on. If this fails, and the caution light stays on, switch off the battery. For a single generator fault, actions are similar for both DC and AC. For a DC fault, the EPCU will automatically close the main bus tie. Try cycling the relevant gen switch off and on. If this fails, switch off the generator. For an AC fault, the GCUs will provide cross-tie. During AC cross-tie, neither galley bus will be powered. This is called load shedding. Like the DC system, try cycling the relevant gen switch off and on. This time, it worked. Similarly, for generator hot conditions, you simply turn off the generators. The EPCU or AC GCUs will provide cross-tie. Loss of two DC power sources is not a major problem. For example, with both DC generators out of action, the EPCU reroutes power by closing the vertical bus ties, so that the TRUs are powering the whole DC system. With both TRUs not working, the vertical bus ties also close, and the DC generators power the secondary feeder buses. But if you lose both AC generators, then you will lose AC services, because there are no inverters to convert DC to AC. Similarly, you will also lose services in the event of an AC bus fault, since the AC cross-tie feeds in upstream of the AC buses. For a left AC bus failure, you lose these services, and for a right AC bus failure, these services. Consult your manual for the exact details. Now some examples of the extremely rare loss of three power sources. After a left engine failure in flight, both the left DC generator and left AC generator are unpowered, but the DC and AC cross ties reconfigure like this. If DC generator number 2 now also fails, the EPCU will open the main bus tie, the vertical bus ties will close, and AC generator number 2, via the TRUs, will power the whole system. However, you have no margin for error left, and should land at the nearest suitable airport. Another example. In the case of a loss of both DC generators and one TRU, the remaining TRU has enough capacity to power the secondary buses, but not the main buses. The EPCU opens the vertical bus ties and disconnects the batteries from the main feeder buses, so that the main feeder buses are unpowered. This is emergency mode. The batteries are only powering the essential buses and the battery bus. Normal practice is to isolate the batteries. Touch each battery switch to switch it off. You have limited battery power for essential services. The cabin pressure controller will not be powered, so you should descend to below 14,000 feet and land as soon as possible. Refer to your abnormal checklist. Now, not the loss of a power source, but loss of an important main DC feeder bus. If you see the DC bus caution light, the EPCU will protect the relevant batteries, in this case the standby and auxiliary, by isolating them from the faulty bus, illuminating their caution lights, and will also isolate the DC GCU. You should firstly switch off the batteries. Touch both battery switches. Then switch off the generator. Touch the gen switch. Next, try to reset the bus using the spring-loaded switch on the DC control panel. Touch the bus fault reset switch. If the bus fault is still there, then leave the switches off and land at the nearest airport. But if the reset worked, then the EPCU will cross-tie power to the main feeder and distribution buses. However, leave the battery and DC gen switch off as a precaution in case the fault reappears. If you see the DC bus caution light but no battery cautions or DC gen cautions, then you simply reset the bus fault and continue as if it never happened.